Now we're going to determine the scale for our x-axis. First thing I do is count how many grid lines I have available to work with. So starting down here at the end, I've got 1, 2, 3, 4, 5, and I keep counting all the way out. And somewhere out here, I find I have about 70 grid lines to work with. Now that I know how many grid lines I have to work with, I look at my range of values I have for v squared. They start at 13.05 and they go all the way up to 22.46. The units for v squared is meters per second squared because v is meters per second and we're squaring it. So if I start my x-axis at 13 and go all the way up to 23, it includes all of those points. 13.05, 14.22, all of them fall within that range. So 23 minus 13 means I have to have a span of 10 units of v squared, 10 meters per second squared, along my x-axis. So I take my 10, divide it by 70 lines, and I get 0.14 meters per second squared per line. That's a pretty small number. I could round up to 0.15. I think I'm just going to round it up to 0.2. Remember, we always round up. Otherwise, if you round down, you run out. You get out to the end of your axis and you run out of space before you get to your biggest value for v squared. So if you round up, that never happens. So I think I'll use 0.2. What does that mean? It means if I start with 13 at the end of my axis, then each line, each grid line on my graph paper increases by 0.2. 13.2, 13.4, 13.6, 13.8, 14, 14.2, 14.4, 14.6, 14.8, 15, and I could keep going all the way up to 23. I've added the scale to my x-axis. Because I had a little extra room, I started at 12 instead of 13, and I went up to 24.